Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study what is path of contact, arc of contact, and contact ratio problems. So this is the problem. The two gears have a module pitch of 4 mm. The number of teeth on gears 1 and 2 are 40 and 24 respectively. Number of teeth, capital T equal to 40 and small t equal to 24. And the module is given here, module M equal to 4. And if the gear 2 rotates at 600 rpm, that is 600 rpm, determine the velocity of sliding when the contact is at the tip of the tooth of a gear 2. Take addendum equal to 1 module. Also find the maximum velocity of sliding. Here we can consider the gear 1 and gear 2 are the larger wheel is the driving wheel is considered as gear 1 and the pinion is considered as gear 2. Then in that case the path of recess, by using this condition, the condition given is that determine what is that the velocity of sliding when the contact is at the tip of the tooth of gear 2. Here by considering gear 2 is pinion, that pinion is considered as a driver. So the tip of the driving wheel is in contact with the tooth of the driven wheel at the end of the engagement. So that means it is the path of recess. The path of recess equal to path of recess means the formula for path of recess is under square root of RA square minus R square cos square phi minus R sin phi. We know that RA comes under that RA equal to pitch circle radius plus module M. Then R equal to that is M into small t by 2. What is that? M is module 4 into t, 24 by 2. That is 48. That RA is 48. That RA equal to 48 plus 4, that is 52. Then RA equal to 52. And we know the pressure angle. The pressure angle is that the pressure angle cos 20. That is pressure angle is the 20 degrees. That was given here, 2 degrees having. Okay, pressure angle is cos 20 minus R sin phi. The R is 48 millimeter and sin phi is 20 degrees. Substitute over here, the path of recess comes observed as calculated as 9.458 millimeters. Now the velocity of sliding equal to, the velocity of sliding is omega p plus omega g times the path of recess. That omega p equal to 2 pi n by 60 and it is omega g is 2 pi n by 60 and path of recess again 9.458. Here if we make it here 2 pi n by 60, then the value comes in terms of millimeter per second. If we substitute 2 pi n, it comes per 6, that is per minute. So the formula for 2 pi n by, that is 2 pi by 60 np plus ng times path of recess. Alright. So that is the velocity of sliding. 2 pi by 60 np. What is that np value here? 600 np pinion. What is the ng? This ng comes from the velocity ratio, that is np by ng equal to tg by tp. If you substitute here np by ng, then the ng is calculated as 360, that is 9.458 times, then it is 950.8 millimeter per second. That is the path of recess. Now the value is there, path of recess is the value 9.458. This is the velocity of the sliding when the contact is at the tip of the tooth of gear 2. Gear 2 is considered here, it is pinion. Gear 1 is considered as, that is the gear, larger wheel. And by considering the take addendum, that is 1 module. Next, what is the second objective? The second objective is again, in case the gear wheel is the driver, before case pinion is the driver. Now if the gear wheel is the driver, the tip of the pinion will be in contact with the flank of a tooth of a gear wheel at the beginning of the contact. So it is required to find out it is required to find the distance of the point of contact from the pitch point. The point of contact from the pitch point, that is path of approach. Here the path of approach is found from the dimensions of the driven wheel, which is again here driven wheel is what? Pinion. So the path of approach is very important if you understand the concept. So what is path of approach and path of pinion, path of recess? While solving the formula of path of approach and while deriving the formulas of path of approach and path of recess, there we considered the driver wheel. This is the path of approach. The driver wheel is the larger gear wheel and pinion is the follower. Now based on this concept, here the path of approach becomes again RA square minus R square cos square phi minus R sin phi. That is 9.458. Again, what is the velocity of sliding? The velocity of the sliding equal to omega p plus omega g, omega p plus omega g times path of approach. Now here, that is omega p 2 pi by 60, that is np plus ng times path of approach. Substitute over here the values of speed of pinion and speed of the gear and the value of path of approach, that is 9.458 millimeters. Then we can observe the value of velocity of sliding, that is 950.8 millimeters per second. So it is one thing is that we can understand the both values velocity of sliding is same. That means in the before case 1, the gear wheel the gear, that means the driver wheel is pinion. In the case 2, the driver wheel is gear. So in spite of whatever pinion or gear, the velocity of the sliding is same whether the contact is at the tip of the pinion. Okay, that's why it is immaterial whether the driver is the gear wheel or the pinion. So what if we consider driver wheel is pinion, the velocity of sliding is observed as 950.8 millimeter per second. And if the driver wheel is the gear, then the velocity of sliding is same as before case 1. So it is immaterial. That is the conclusion. Whether the driver is either gear or pinion, whatever it may be, the velocity of sliding equal to 950.8 millimeter per second. So that is the conclusion from this problem we can understand. Now, next one is that for other cases, the maximum velocity of sliding. One more thing is that it is depend upon the larger path considering any of the wheels to be the driver. So considering pinion to be the driver, the path of recess, now before path of approach we consider the path of recess 9.458 millimeter. Now if we consider the path of approach, that value is the larger value, that is 10.117 millimeters. That is the formula RA square under square root of RA square minus R square cos square phi minus R sin phi. How to get it is R? Capital R equal to small m times capital T by 2. RA equal to R plus m. So the small m is 4, capital T. What is the mod? That is 40 by 2. That is 240 is 80. So R equal to 80 millimeters. RA, that RA equal to R plus m. What is that R? Here. That R is we obtained here. What is the R? That R equal to 80 plus module m 4. That is 84. So RA equal to 84 and RE equal to 80. The pressure angle we observed here, it is 20 degrees. After substituting all the known values in this formula of RA square, the path of approach, the observed value is 10.117 millimeters. That is path of approach. Alright. Now, what is the maximum velocity of sliding? The velocity of sliding is omega p plus omega g times maximum path of approach. Then substitute over here those values, that is omega p plus omega g. That is 2 pi by 60 times np plus ng. Okay, into maximum path of, that is 10.117 path of approach. Then the value is 1017.1 1017.1 millimeter per second. So there is a manner we can understand that the what is maximum velocity of sliding. Find the maximum velocity of the sliding. Next model, if we consider here two 20-degree involutes per gas mesh externally and give a velocity ratio of 3. The module is 3 millimeters and the addendum is equal to 1.1 times module. Addendum equal to 1.1 times m module. If the pinion rotates at 120 rpm, that is np equal to, this value is 120, determine the minimum number of teeth on each wheel to avoid interference. And second objective is contact ratio. So this is very important model. Here we have to find out the minimum number of teeth on each wheel in order to avoid interference. That interference means causes damage while running. So in order to avoid interference means contact. What is the minimum number of teeth on each wheel should have. And second objective here it is observed, this is a contact ratio. The contact ratio equal to arc of contact over, that is arc of contact into PC, circular pitch. Now what is arc of contact? Path of contact by cos phi by PC. What is the path of contact? Path of approach plus path of recess. So in that manner we have to solve the problem. So the problem here begins. The given data is 5. There is a pressure angle equal to 20 degrees. The revolution, the speed of pinion speed is 120 revolutions per minute. The velocity ratio is given as 3. Addendum equal to 1.1 module and module equal to 3 millimeters. And very important here it is, that is AW. That is AW equal to 1.1. That is 1.1 times module. That is AW times M. Now here it is, that means AW equal to 1.1. Now the formula for in order to avoid interference on each wheel is capital T. The number of teeth on the larger wheel equal to 2 times AW by under the square root of 1 plus 1 by g times 1 by g plus 2 sin square phi minus 1. We know the gear ratio. What is the gear ratio? Is nothing but, that is velocity ratio. Okay, that is gear ratio G equal to 3. That is also capital T by small t here. Now that is here 2 point AW equal to 1.1 by under square root of 1 plus what is G 1 by 3. Substitute over here, the pressure angle is 20 degrees minus 1. So capital T, the number of teeth on the gear equal to 49.44. So this is so taking the highest whole number divisible by, okay, then that is how much it is. This 49.44, that round figure is 50. We can consider it. But the standard gear is number of teeth available, that is 51. Next, that is go to. So capital T equal to 51. Then gear ratio G equal to capital T by small t. Capital G is 3, capital T, that is 51 by small t. The T equal to 51 by 3, that is 17. So in order to avoid interference, the minimum number of teeth on each wheel should be, on larger gear wheel is 51 and pinion should have 17 teeth. In order to attain the gear ratio of 3, that is the condition. The next, that is contact ratio. In that contact ratio, we need the values of RA, capital RA and capital R, that is the pitch circle radius of the gear, and addendum circle radius of gear, and addendum circle radius of pinion, and pitch circle radius of pinion values are required in order to calculate the values of the objective of contact ratio. Here Now, the contact ratio means, what is the meaning of contact ratio? Contact ratio means the number of pairs of teeth are in contact. The meaning is, but that ratio comes as arc of contact by circular pitch. The circular pitch is pi m. What is the arc of contact? Path of contact by cos phi. What is the path of contact? Path of approach plus path of recess. What is the path of approach? That is RA square under square root of RA square minus R square cos square phi minus R sin phi plus per pinion approach, that is under square root of small RA square minus R square cos square phi minus R sin phi. This is the sum. Approach plus recess by cos phi times pi m. So we need the values of the pitch circle radii of both gear and pinion and addendum circle radii of both gear and pinion. Now, how to get it that RA? And now R equal to mt by 2. What is that? M is 3 times module capital T 51 by 2. That is 76.5 millimeter. Now RA equal to R plus 1.1 times in order to avoid addendum equal to, that is 1.1 times module. That is RA equal to R plus 1.1 times M, where M is module, that is 3. 76.5 plus 1.1 times 3, that is 79.8 millimeters. That is RAR. Next, those are the values related to the gear. Now we need the values related to pinion, that is RA and smaller. What is RA equal to again? R plus 1.1 times M. Now that is 28.8. What is R equal to small? That is MT by 2. That is 3 times 17 by 2. That is 25.5 millimeters. Alright. Now RA we know R and also RA. What is the pressure angle? Phi equal to 20 degrees. Substitute all these known values in the mentioned the formula, that is contact ratio. The contact ratio formula, that is RA, that is 79.6, 79.8. Capital RA square minus R cos phi whole square, that is R square cos square phi minus R. What is that? R is 76.5 sin phi 20 plus small letters, that is related to pinion, path of recess, that is RA square, that is 28.8. 28.8 whole square minus R square cos square phi means R cos phi whole square. What is small r? 25.5 cos phi cos 20 whole square minus R sin phi. R sin phi 25.5 sin phi. Though then the term comes as 1.78. What is the meaning of contact ratio equal to 1.78? That means the meaning of contact ratio, that is 79 point, that is 1.78 meaning is that one teeth is completely engaged and another one is 78% of the teeth is in contact. That is the meaning of this. That is 1.78. If the contact ratio is 2, that means two teeth are complete in contact, 100%. If contact ratio equal to 1, that is only one teeth is in complete contact each other. Okay, then what will happen here? That is the meaning of the contact ratio. If the contact ratio is 3.58, like that, no, there is certain limitations. All teeth are at a time not in contact. It depends upon the size of the gear wheels. If the gear wheels are not, depends upon the geometry of the gear and pinion, the number of teeth are in contact. Now, the contact ratio is dependent on the parameters of addendum circle and pitch circle radii of both pinion and gear, and also it is dependent on contact ratio is dependent on pressure angle. So the contact ratio N is dependent on RA, R, small a, R, and pressure angle. These are the five parameters. This contact ratio is dependent. Now, if the contact ratio varies by varying RA, R, capital letters, that is, and also anyone In relation to that, it will vary. So that's why it is dependent on. So if suppose if the addendum circle radius is increasing, what will happen to contact ratio? It increases. Or any one parameter is increasing, or especially the addendum circle and pitch circle radii of pinion gear are changing, the contact ratio will be changed. So next terminology, that next problem is that next model, two involute gears in a mesh, are in a mesh, have a velocity ratio of 3. Again here, velocity ratio of 3. The arc of approach is not to be less than circular pitch. That means the arc of approach is equal to circular pitch when the pinion is the driver. That is the meaning here. Arc of approach equal to circular pitch. That is the meaning. The pressure angle of the involute teeth is 20 degrees. That is phi equal to 20 degrees. Determine the least number of teeth on each gear. Also find the addendum of the wheel in terms of module. So we have to find out the addendum of the wheel and also the least number of teeth required on each gear. These are the two objectives we have to calculate. Now, the given data is only two parameters, that is pressure angle and velocity ratio. And one condition is that arc of approach equal to circular pitch. That is not to be less than. The meaning is that it is not more, then it is equal. Now, arc of approach equal to circular pitch, that is pi times m. Now, arc of approach equal to path of approach by cos phi. So, arc of approach equal to circular pitch pi m. That is path of approach by cos phi equal to pi times m. Path of approach equal to pi m times cos phi. Now, pi m times, what is the pi m? M given here. What is the velocity ratio? M not given. What is phi equal to 20 degree? This path of approach comes in terms of module, that is 2.952 m. Now, what is the maximum length of path of approach? The maximum length of path of approach, that is, the formula for this is r sin phi. That is small r sin phi. Now, what is the small r equal to m into small t by 2 sin phi. What is the m here? We don't know the unknown m. What is the t? Velocity ratio 3 given. We don't know the t. Sin phi I know. What is the phi is 20 degrees by 2. So, this is 0.171 small mt because number of teeth and pinion unknown and the module values also unknown. But we have to calculate this addendum in terms of wheel, in terms of the module, in terms of module m. So, not required that m value, but we need t value here not given. So, let us see what will happen. That is 0.171 mt. Now, this maximum length of path of approach, that is 0.171 mt equal to 2.952 m. Here mm cancel, that is t equal to 17.26. That is nothing but what? 18 teeth. That is 18 teeth. Now we know the velocity ratio. That is velocity ratio. Capital T by small t. That means what will happen? Capital T equal to VR times small t. Alright. What is the VR times? What is the velocity ratio? 3 times small t. Just now 18. 18 3 is 54. So capital T is 54. That is what? Least number of teeth on each gear. So the least number of teeth on each gear is, on each gear means on gear wheel, larger wheel is 54 and the smaller wheel is how much? 18 teeth. Such a way that the velocity ratio can be reached 3. The velocity ratio can be reached to 3 value. When capital T equal to 54 and small t is 18. Alright, this is the manner we have to solve. Next one, find the addendum of. We have to find out the addendum of the wheel. We have to find out the addendum of the wheel. What is that addendum of the wheel? Next, that is maximum addendum of the wheel. The maximum addendum of the wheel is AW maximum. This is the formula, that is m into capital T by 2. That is times under square root of 1 plus 1 by g times 1 by g plus 2 sin square 5 minus 1. This g is, what is the g value? Is the velocity ratio or gear ratio here. Gear ratio or velocity ratio, that is the term. Gear train value is different from speed ratio. Now that is velocity ratio or gear ratio, and phi is the pressure angle. Phi is pressure angle. And m is module in terms of, that is m equal to module. Capital T, number of teeth on gear. Now this is the maximum addendum of the wheel. The maximum addendum of the wheel, AW maximum equal to m into capital T by 2 times under square root of 1 plus 1 by g times 1 by g plus 2 sin square 5 minus 1. Now substitute over here capital T value, that is observed here, it is 54. Small m is module. We want this maximum addendum of the wheel in terms of m module, that is m times 54 by 2 under substitute over g and phi, then it is 1.2 module. So these are the problems we can understand. Today in this class we covered various problems, and here very important that the path of approach is dependent on the addendum radius of the wheel. Addendum radius, path of approach is addendum radius of the wheel or larger wheel gear, and the pitch circle diameter and pressure angle. The path of approach is dependent on RA, R and phi. Path of recess is also dependent on pitch circle radius small RA, R and phi. That is related to pinion values, path of recess. So both path of approach and path of recess, the common is dependent on one thing, that is the pressure angle phi. So in this manner, and very important is that when two teeth are in contact, then two pitch circle are in contact, then that point is known as the pitch point. Pitch point is the junction point for path of approach and path of recess. So the distance from path of approach is the distance from beginning of engagement to the pitch point is known as path of approach, and the path of recess is distance from pitch point to end of engagement. That length is known as path of recess. The sum of path of approach and path of recess is known as contact length or path of contact. This complete path of contact, if you draw a straight line, then it gives the line of action. And one more thing is that when two pitch circles, what is the pressure angle? The angle between this line of action normal to the pitch point, the normal to the contact, that is known as the pressure angle. So this pressure angle, the effect of pressure angle is very important, that it damages the gears and pinions during contact. And also while designing the gear wheels, one has to consider the circular pitch and the radius of the addendum. What is addendum, what is module, and also the radius of pitch circles of both pinion and gear. And in spite of whatever the pinion, it is immaterial whether the gear wheel is in contact. It is immaterial. It is immaterial whether, one thing is that yes, It is immaterial that whether the driver is pinion or gear, but the velocity of the sliding is the same when the contact is at the tip of the pinion. That is the meaning. When the contact is at the tip of the pinion, whether the gear wheel is a driver or a follower, it is immaterial. So these are the important points we have studied in this session. And one more thing is that path of approach and path of recess formula, what we have derived from the concepts is that we consider by deriving the path of approach or path of recess or path of contact and contact ratio and arc of contact, considered larger wheel is the driver and smaller wheel is the follower. Okay, and this is the way of understanding of what is the velocity of the sliding. The velocity of the sliding is the sum of omega p. Angular velocity of omega p and omega g are sum multiplied by a path of approach. This is the maximum velocity of the sliding. And the path of contact length in path of approach is larger than the path of recess value. So that means the time taking for path of approach is more than the path of recess. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.